What's going on, people? Mr. C here with lesson 11.3. Going to be going over surface area again today, but specifically for pyramids and cones. All right, so we're going to start with pyramids today, and then tomorrow we'll take care of cones. So let's go ahead and get started. Pyramids, let's talk about those first. All right, though probably looks like a lot going on in these pictures here. Let me explain. Okay, so let's go over these two on the left before we talk about this. So, a lot of different parts to a pyramid. First, I want to go over the difference in naming these pyramids. Okay, notice this one up here, we refer to this as a hexagonal pyramid. The bottom one here is a square pyramid. So, how we name pyramids is solely on their base, kind of like how we named prisms. So, since this base is a hexagon, we refer to this as a hexagonal pyramid. This base here is a square, so we refer to this as a square pyramid. All right. So every pyramid has a base. They have one of those. All right. Lateral edges are basically all these lines that come up and meet at the top point, which is called the vertex. So we have our lateral edges. They meet from the base and they meet at the vertex. Okay. These ones around the edge are the base edges, or around the base are the base edges. Now we have an altitude, which goes straight from the center of the base straight up perpendicular to the vertex. So this line is basically perpendicular to this base here. All right. So most important parts to know is we have a base, and this is the altitude, or we're going to refer to it as the height. Now, looking down here, there's actually two different kinds of heights in these pyramids. We have the height that's straight down, perpendicular, goes through the center of the pyramid, and then we also have the slant height. All right. The slant height is the one we're going to use for surface area. Later, when we go over volume, we're going to be using the height because volume deals with the insides of shapes, not the surface area. So, the slant height is the height that we're going to want. So imagine I folded all these flaps down in this square pyramid. This is what it would look like. Okay, so this slant height here, okay, those are all the heights of the triangles that are these lateral faces. Okay, pyramids are made up of one base and then a bunch of triangles, depending on how many sides the base has. So the area of each one of these triangles is 1/2 of base times height, or in this case, S times L. So if we're going to want to find the surface area, we're going to need to find the area of all of these triangles. So if you find the area of one triangle, multiply that by 4, that's going to cover all your lateral area, and then you need to add the area of the base as well. So as a formula, okay, that's going to look like this. The lateral area, all right, that is 1/2 the perimeter of the base times L, and then the surface area is basically just that part. So the surface area is 1/2 PL, but then you need to add to it the area of the base. So let me say again, P represents perimeter of the base. L represents the slant height. And capital B represents the area of the base. All right, so those are my formulas for surface area of a pyramid. So again, just adding up all those triangular faces, depending on how many there are, and then just add to that the area of the base, and that is your total surface area. Let's go ahead and go over an example. All right. So we're dealing with here let's see, 1, 2, 3, 4, 5, and 6. So this is a hexagonal pyramid. So we want to find the surface area, which again, I'll write down the formula, is 1/2 PL plus the area of the base. So let's try to identify what we have first. Do I have perimeter? they tell me this distance is 6, and if I know I have 6 sides, 6 plus 6 plus 6, or you could do 6 times 6 for perimeter. 6 times 6 will give us a 36. These are in inches. All right. L again represents the slant height, which is not the one that goes straight down in the middle. I don't even have that, but it's the one that runs down your lateral faces. So that's a distance of 9. Right. And then the only other thing I need is capital B, which represents the area of the base. So this is the base. I need to find its area. So do you recall, how do we find the area of a hexagon? That was those regular polygons. Section was 10, somewhere in chapter 10, I believe. Finding the area of this triangle and multiplying it by how many triangles we have, or it was 1/2 AP, apothegm times the perimeter. Remember, the apothegm was the height of this triangle here. So if we're trying to find large B, that is 1/2 the apothegm, which is 3√3, times the perimeter of the base, which we already said was 36. All right. So let's figure out what that is. Let's go to our calculator. That was 1/2 of 3 square root 3. Oops, let me add some. Okay, 1/2 of 3 square root 3 times 36. All right, gives me a 93.5. So this 93.5 inches squared. And then let's calculate everything together. So this was 93.5 inches squared. If we're plugging it all into this formula, okay, how I kind of like to do these is to first find everything you need, have those organized off into the side, and then plug each one of these into my final formula for surface area. So that's what we're going to do now. So my surface area is 1/2 of P, which is 36, times L, which is 9, plus 93.5. Okay, let's plug this part into our calculator. 1/2, oops, 1/2 of 36 times 9 gives us a 162. Okay, add 93.5 to that. So 162 plus 93.5 gives us a 255.5. Surface area is equal to a 255.5 inches squared. Okay, so that was my surface area for this guy. All right. Let me know if you guys had questions on that. For today, we're going to stop. If you'd like to continue on in the video, that's fine. We're going to do cones next. If not, go ahead and try today's homework. But we are going to move on. All right. Let's go ahead and do that. Stock cones. Okay. Cones aren't too bad because kind of like how we did prisms and cylinders, how cylinders, the base was always a circle. For cones, the base is always going to be a circle. So there's kind of less to look at. So rather than finding the area of like a square or hexagon, we'll always be finding the area of that circle. And the formula is very similar. Okay. The lateral area for this guy is going to be pi times the radius times slant height. And then the surface area is going to be that pi RL plus the area of the base, which is pi r squared. Okay, pi r squared. And that is going to give me the surface area of this cone. All right, pi RL plus pi r squared. Pi RL takes care of all of the part around the outside, and then pi r squared takes care of the base part here. So let's go ahead and find this next example right here. Okay, where we are asked to find the surface area of this thing. Okay, surface area of, this is called a funnel. Now, this is kind of tricky because if you're just asked to find the surface area of a funnel, if you're just looking at the picture, you might think, okay, if I just find the surface area of this cone, I'm good. But think about how a funnel works. There's no surface here, right? There's no surface. It's open, so you can pour stuff into the funnel. So what we're going to use is the lateral area formula this time. Reason being is because pi r squared covers the surface of the base, but we're not counting that because, again, a funnel, the base is non-existent here. It's open, so you can pour stuff into it. So we're really just using the pi r L portion. So let's find that lateral area. We said was pi r L. Okay. Things I do know the radius, right? And it's not 80. It's saying 80 is actually the diameter, which makes the radius should be 40. It's going to be half of that. So radius is 40 millimeters. And L is the slant height. Now I'm not given the slant height here. I'm actually just given the regular height. The slant height is this distance. So think of a way I can find this. All right. This is pretty much, you can see here, well, I shouldn't say pretty much, this is a right triangle there. Right? Okay, that's a right triangle. So I can use Pythagorean's theorem on this thing. This distance here is 40. This was 45. This is the hypotenuse. So I can say 40 squared plus 45 squared equals, let's call this L, equals L squared. That's my A squared plus B squared equals C squared formula, Pythagorean's theorem. So let's figure out what that is. 40 times 40 was at 1600. 1600 plus 45 times 45 is 2025 equals L squared. Let's add those two up. 3625 Let's see if that is a perfect square. Let's take the square root of 3625. And I got about 60.2, so not a perfect square, but that's okay. We can still use that. L, it's about 60.2. What was that in millimeters? All right. So that gives us L. And then we can just go ahead and plug those in. So my lateral area is pi times 40 times 60.2. Okay, plugging that all in, you get 7,560. We'll run that to 65. 7565. 75, 65. It's a surface area, so these are millimeters squared. All right. Now, if this wasn't a funnel and it was just a regular old cone, what you would do next is add pi r squared, okay, because that would include the base. But this being a funnel, we're not going to include that. And 75, 65 millimeters squared is going to be our answer. All right. That is all I have for today. Hope you guys are doing well. Miss you guys. Let me know if you have any questions. Leave comments. Do whatever you got to do. Email or in Zoom. Okay. I'll talk to you later. Peace.